Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 36, Gases Part 2. Here are our objectives for today's video. Pause here. Right, I'm going to walk you through this. There's multiple ways to answer this question, but this is just a really, really important skill. I'm going to show you just the way that I like to do it, but that doesn't mean it's the only way. So if you're ever trying to derive a relationship between any two variables, it doesn't just work with PV equals nRT, but we're mostly going to apply it to PV equals nRT. What I like to do is I take the variables and I put them on the left side of the equal sign. And then I take my constants and I put them on the right side. So here it's between volume and temperature. So if I do a little bit of algebra, I get that V over T is equal to N times R over P. Then from here, I could just say that my left side of the equation is equal to a constant. Or the way that is most useful, because we can apply it to calculations, is that V1 over T1 is equal to V2 over T2. And what that really means is that if I have I'm at constant number of moles and constant of pressure, if I have say 500 milliliters or something and it's at a certain temperature, without knowing the number of moles or without knowing the pressure, if I know that the final temperature, I could figure out what the final volume is too. I only need this equation here. I don't need all of the other factors of PV equals nRT. Pause here. So this is just another way of saying exactly what I just wrote. So volume is equal to B is just an arbitrary constant here. It doesn't have to be called B. You could literally call it whatever you want, times T. What you should recognize when you see this is a direct relationship. V over T is another way of expressing a direct relationship. Pause here. Okay, so this is a very, very similar process. So we want in this one, we want pressure and volume. And it already works out that pressure and volume are on one side. Or another way to write this is that P1 V1 equals P2 V2. Pause here. So this is Boyle's law. Pressure times volume is equal to an arbitrary constant. I could call it K, but it doesn't really matter what I call it. This is an indirect relationship. If I increase pressure, I'm going to decrease volume, though normally we think of it as being the other way around. Just to clarify, none of these laws, like Charles's law, Boyle's law, Avogadro's law, none of these actually came originally from the ideal gas law. It was the other way around. But it works out better to use the ideal gas law to derive these when you have to do problems pretty quickly, because I'm not going to be giving these equations to you, nor do I expect that you have them memorized. Personally, I actually derive them each time I do a calculation. Pause here. Right, same process here. On my left, I want volume and number of moles. So I could express it as V over N is equal to a constant, or V1 over N1 is equal to V2 over N2. Pause here. Which what we just did is just Avogadro's law. Volume and number of moles are directly related to another at constant pressure and constant temperature. Great. That's all for tonight. Thank you so much for watching and have a great night.